unbalanced assignment problems. Here number of rows will not be equal to number of columns. So first we will make number of rows equal to number of columns. See this question. Here P, Q, R, only 3 columns are there, but 4 rows are there. So we will add one more dummy column, P, Q, R, S. We are adding one dummy column S so that all cost is 0. Similarly, see the question here. Here 1, 2, 3, 4. 4 rows are there, but 1, 2, 3, 4, 5. 5 columns are there. So here one row is missing. Here we will add one more row, E, so that all elements of E are 0. Okay, so unbalanced assignment problem. First we will make number of rows equal to number of columns by adding one more dummy row or dummy column. Here we have added one dummy column for making the problem balanced. That is, for making number of rows equal to number of columns. So first we balance the problem. Now all steps are similar. First is row wise minimization. First row minimum is 0. Second row minimum is 0. Third row minimum is 0. Fourth row minimum is 0. Every row minimum is 0. So no need of minimization. So in this case, first step is column wise minimization. Column wise minimization. First column minimum is 8. 9 minus 8, 8 minus 8, 20 minus 8, 21 minus 8. Second column minimum is 12. From all elements subtracting 12. 13 minus 12, 15 minus 12. Third column minimum is 11. Subtracting 11 from every element of third column. Last column, dummy column. Okay, so first step over column wise minimization. Draw minimum number of lines to cover all the zeros. So let us cover all the zeros by drawing lines, number of lines which is less than 4. Why 4? 4 is number of rows. 1, 2, 3, 4. 4 rows are there or 4 columns are there. So we will try to cover all the zeros within 3 lines. 4 zeros I have covered. 2 zeros I have covered. These 2 0 we have to draw 2 lines. We cannot cover by single line. 1, 2. So minimum number of lines to cover all the zeros equal to 4. Number of columns equal to 4. Number of rows equal to 4. So minimum number of lines to cover all the zeros equal to number of rows. Number of rows or number of columns. So this is our final matrix. Writing this matrix clearly. 1, 0, 0, 0. 0, 1, 6, 0. 12, 0, 2, 0. 13, 3, 6, 0. Since this is final matrix, I am giving the column name and row name. Column name they have given A, B, C, D. No, row name they have given A, B, C, D. Column name they had given P, Q, R. S we added. This is dummy column. Start the allocation since this is final matrix. Starting allocation means searching single zeros. Row wise searching single zeros. First row 000. Second row 00. Third row 00. Last row, yes, single 0. Row wise searching, so cut all 0 from column. First column Yes, single 0. In row, no 0 for cutting. Second column, double 0. Third column, single 0. We were searching column wise, so row wise cutting zeros. Third column over, last column, no 0 because one already allocated, remaining all are cut. So row wise searching over, column wise searching over, again row wise searching. First row, second row, third row, no 0 for cutting. So our allocation over, A allocated to R, A R. B allocated to P, B P. C Q, C Q. D S, that is dummy column. D is allocated to this dummy column. So the job A go to R, the job B go to P, the job C go to Q. D is not allocated to anyone because this is not given the question. We have made this dummy column. So D nil. So total is 31. 31 rupees. Whatever is given in question, that unit you add. Unbalanced assignment problems. Unbalanced means number of rows and columns are not equal. The matrix is not balanced. Here you can see 1, 2, 3, 4, 5. 5 columns are there. 1, 2, 3, 4. Only 4 rows are there. So first step, adding one dummy row so that all elements are 0. Now number of columns equal to 5, number of rows equal to 5. Now the problem is balanced. First step is row wise minimization. Row wise minimization. First row minimum is 9. Subtract 9 from each element. Second row minimum is 9. Subtract 9 from each element. Third row minimum is 7. Subtract 7 from each element. Fourth row minimum is 7. Subtract 7 from each element. Last row minimum is, last row is dummy row. Row wise minimization over. Now no need of column wise minimization because every column minimum is 0. So next step, directly drawing minimum number of lines to cover all the zeros. We are going to cover all the zeros within 1, 2, 3, 4, 5. 5 minus 1, 4. Within 4 lines, we are going to cover all the zeros. All 5 zeros within one line. This 0, this 0, this 0, this 0. No, we required 1, 2, 3, 4, 5. 5 lines we required to cover all the zeros. Minimum number of lines to cover all the zeros equal to 5. But 5 is equal to number of columns 1, 2, 3, 4, 5. Or 5 equal to number of rows. Okay. So minimum number of lines equal to number of rows or number of columns. So this is our final matrix. Rewriting it clearly, 0, 2, 6, 1, 2. Similarly all elements I am writing. This is the question. This is the final matrix. Start the allocation. First row, single 0. Yes, there is a single 0. Circle it. cut all 0 from corresponding column. Second row, yes, there is a single 0. Circle it, cut all 0 from corresponding column. Third row, yes, there is a single 0. Circle it, cut all 0 from the column. Fourth row, there is a single 0. Circle it, cut all 0 from the column. Only one 0 remaining, allocate it. So, this first 0, that is this one. 1, 2. Second one, this one. 1, 2, 3, 4, 5. Last one, this one. 1, 2, 3, 4. 1, 2, 3, 4, this one. 1, 2, 3. No need of mentioning this one. Only circle it and we are not allocating this job. So, 9 plus 9 plus 7 plus 7. 32.